My name is Sahib Khalsa. This is Nick Obradovich. We're pleased to be chairing this session today entitled Artificial Intelligence Language Models, and Psychiatry Opportunities and Perils. We're going to try to take a deeper dive into some of the issues that you heard about in the previous keynote. And we'd like this to be as interactive of a discussion as possible. So in the interest of that, what we'd like to do is each person who's going to present, and you can see the presentation order here, we've got Ajilore first, followed by Roy Perlis, who couldn't make it in person, but we have a recording and we have him live on the Q&A, followed by Waqas Khan and Jina, and then Martin giving the discussant. So after Martin's done with the discussant comments, then we'll open it up for a general discussion, and very much looking forward to the participation from everybody else. So in that regard, we just wanted to start with a few questions just to get the sort of pulse of the audience. So first of all, you can see here a GPT-generated image. Wanted to just get a show of hands from the audience, if I may. How many of you have ever used a large language model such as ChatGPT or Bard, ever in your life? Okay, that's about 95% of the room. How many of you have used one in the past month? Okay, about the same amount. Past week? A little bit less, maybe 80%. And how about today? Okay, so about 25%. We'll see whether that changes over time. But last couple of questions. So now that you've heard the previous keynote, in terms of your current knowledge, with respect to the field of psychiatry, how many of you think that the positive clinical applications of LLMs outweigh the negatives? So positives outweigh the negatives. Okay, so that's about 60% of the room. How about the negatives outweighing the positives? One, all right, or co-chair. So should make for some interesting discussion. So on that note, we will move ahead with the first talk, and it's going to be Dr. Ajilore.
Thanks, and thanks for inviting me to be a part of this panel. So today I'm going to talk a little bit about sort of more of the optimistic side of AI in psychiatry, talking about our development of an AI therapy chatbot as part of a study called SPEAK, which is a study of a problem-solving therapy-trained voice-enabled artificial intelligent counselor for adults with emotional distress. And this was a project done in conjunction with my colleague, Dr. June Ma, at the University of Illinois in Chicago. Here are my disclosures. The work that I'm going to talk about today is funded by NIMH. So as part of the SPEAK study, we developed an app called Lumen, which is designed to deliver problem-solving treatment on a mobile device. In the case of our study, we used iPads. And on the iPads were also links to doing ecological momentary assessments and scheduling sessions. And this was connected to a backend in REDCap where we were able to collect research data. And to design Lumen, we used an iterative process where we recruited participants who had experience with in-person problem-solving treatment. And we used a couple of surveys to assess the quality of Lumen. One was a user experience questionnaire where we asked about whether Lumen was fun to use and easy to use. We also used the NASA task load index to look at how demanding it was to use on a number of different domains. We also used a version of the Working Alliance inventory to look at whether there was a sense of therapeutic alliance along different dimensions, like trust and around the goals of therapy. And then we also did a series of semi-structured interviews to get more qualitative aspects of the same domains that we were getting at with the survey. Here are the demographics of the participants who helped us with this iterative design process. And the main thing that I wanted to highlight was that the participant pool was very diverse and mostly female, and that will come up later when we look at the results. So in the survey results, they found that Lumen was relatively easy to use, not as enjoyable, but relatively easy, and that, but it was demanding. There was medium levels of demand in the cognitive domain, some frustration, some issues with the performance of the app. And then, but on the positive side, it scored pretty high on the Working Alliance inventory, where people found that the use of Lumen was highly aligned with their goals for therapy. And so some of the lessons that we learned when developing Lumen was that we actually split up the conversation segments to make it a little bit more easy to use. I would note that this was done based on the Amazon Alexa platform. So we took advantage of the natural language understanding and natural language processing built into the Amazon Alexa platform, but the way users interact with the chatbot is very constrained and stilted because you have to fit it in the format that Alexa will understand. We added some ways to control the flow of the interaction with Lumen by adding pause, resume, and repeat functions. And then we also provided some information to accompany Lumen while participants did their problem-solving therapy sessions. And then we allowed for progression tracking and giving feedback to participants so that they could see how they were doing after each session. So this updated version of Lumen was implemented in a pilot study where after recruitment and orientation, participants engaged in doing a series of baseline surveys where we asked about levels of anxiety, depression. We asked about baseline problem-solving skills and attitudes towards problem-solving and coping. In addition, we also got baseline MRI scans to look at functional connectivity in networks that have previously been shown to be responsive to in-person problem-solving treatment. So those networks were a negative threat network that focused on the dorsal ACC and the amygdala, and a cognitive control network with hubs in the dorsolateral prefrontal cortex. So the participants were randomized to either using Lumen 8 sessions over 12 weeks or a waitlist control group, and then we repeated all the assessments, both the fMRI and the clinical assessments at week 16 after treatment. Here's the clinical and demographic characteristics of our sample. Again, it was mostly women, very diverse. And this was a R61, R33 mechanism, so we had to show that the intervention affected a target of interest that we thought was involved in the mechanism of how problem-solving treatment would improve depression and anxiety in these participants. And so we focused on activity in the cognitive control circuit as well as an improvement in problem-solving skills as our sort of targets of interest for the intervention. What we found was, looking at the cognitive control circuit, that participants who used Lumen compared to the waitlist control showed an increase in activity in the dorsolateral prefrontal cortex during a go-no-go task, which is a task of response inhibition and executive function, that corresponded and correlated with improvements in problem-solving skills. That's what's shown on the left. We did not see that pattern in the waitlist control group. And then those that got Lumen also showed that a relationship between improvements in activity in the dorsolateral prefrontal cortex and a reduction in avoidance styles or sort of maladaptive coping skills. So we showed that the intervention affected our targets of interest, and we saw some modest improvements in depression and anxiety symptoms on the hospital anxiety depression scale with decent effect sizes that allowed us to move forward with our current trial where we're using Lumen in comparison to in-person problem-solving treatment and a waitlist control group. I wanted to highlight one interesting finding was that if we looked at moderators of treatment response, we found that the most robust reductions in depression and anxiety were in women who were non-white with a college degree of education or less. In addition, we saw that there was an inverse relationship between digital literacy and clinical response to Lumen, which at first was kind of counterintuitive, but then we realized that folks with higher levels of digital literacy might be more critical of the technology because they're more aware of how things should work or could work. But the fact that we saw that we got these great responses in non-white women with a college degree of education or less was reflective of the folks that helped us design Lumen in the first place. So I think this is a lesson in terms of having people, stakeholders involved in the design of your intervention from the beginning, as they're the ones that are most likely to have the most beneficial response. So I just wanted to end with talking about how all of this was designed before ChatGPT was available. And so in preparation for this talk, I spent about 25 minutes on Sunday basically creating what took us 10 months to do earlier. And so this is Lumen X, which is a custom GPT that I made. And you can see an example of our interaction here. What I did was I fed it or uploaded a problem-solving therapy manual, as well as a PowerPoint that I found online. I gave it a few custom instructions, and it basically was able to help me with this completely hypothetical problem of procrastination. And what it does is that it takes you step by step through each of the steps of problem-solving therapy. So here, it's helping me identify specifics about my problem with procrastination, and then it will take me in an iterative fashion, step by step, through problem-solving treatment. And what was really interesting was the iterative design process involved in creating the custom GPT is that when I first fed it the information and it was giving me some therapeutic advice, it basically spit out all the steps at once. And so I had to tell it, no, just take me one step at a time. It would give me all the answers at once. I said, no, don't give me the answers. The user has to come up with an answer first, and then if they can't come up with an answer, then give some suggestions, and it did that. And then I want to end with talking about how it's not just problem-solving therapy. I do psychotherapy supervision with our residents, and one of the residents gave me this scenario that I then gave to ChatGPT, where I told it to act as a psychotherapist trained in psychodynamic psychotherapy, treating a middle-aged woman who's depressed and estranged from the adult daughter, and she was sad because she didn't get anything for Mother's Day, but then she bought a plant. So how would you interpret this purchase? And this is what ChatGPT said. It basically talked about how it's related to the depression and the estrangement, and it's a symbolic representation of her unfulfilled maternal nurturing and desire for growth and connection. So, so not too bad, actually. So I will end here with giving acknowledgments and thanks to the incredible team that was involved in the development of Lumen. Thanks.
Okay, so our next speaker is Dr. Roy Perlis. And as I mentioned, he wasn't able to be here with us in person, but he recorded his talk. So I will play that, and then we'll move on to the next one. And hopefully everyone can hear him.
Good morning. Happy to be able to talk to you today. I'm sorry that I can't be there in person. But if I can make the technology work, I want to spend a little bit of time sort of laying out a few projects that we've been involved with in using generative AI in psychiatry, and then hopefully lay out some themes that we can discuss as a group. Here's my obligatory disclosure slide. I'll pause for a moment. So the first project I want to mention is something we started last spring, which aims to answer a really simple question about how large language models do out of the box with no additional training or fine-tuning in terms of making decisions about next step antidepressant treatment. So this project built on the fact that we'd previously validated some clinical vignettes against expert consensus for next step treatment. So each vignette presents a clinical situation, then says, what's the right next step option? And you can see on the screen the general prompt that we used in this case for GPT-4 to say, what's the right next step treatment? And we did various things to play around with this prompt, which we can maybe come back to later. And the design of the experiment was presenting each of these vignettes multiple times in random order, permuting the sociodemographic features for reasons we can come back to. And then we just compare how well this model does to expert clinicians in picking one of the right next step treatments. And it's sort of a glass half full, glass half empty story. So if you look at the left side of this figure, about 3/4 of the time the model could pick one of the right next step treatments, at least option that was concordant with the experts. For 7 of the 10 vignettes, it got it every time. For some of the others, and 2 of the others, it never got one of the optimal answers. And in some ways, more interestingly, about half the time it recommended an option that was either considered poor by the experts or even contraindicated and potentially dangerous. And for a number of vignettes, it did it every single time. But maybe more interestingly, intermittently, it would make the wrong choice or advise the wrong choice. And I think this is, in a lot of our work with decision support and machine learning in general, this is something that we see. The models are, when they're good, they're very, very good. And when they're bad, they're horrible. Again, probably an important theme for us to come back to. A second project, which is going to be published in New England Journal AI in a week or two, is a totally different application of large language models, which I think takes advantage of their ability to adopt or to undertake new tasks that are, broadly speaking, natural language processing, but maybe a little bit different from the sort of natural language processing that we would traditionally do. I've hypothesized for a long time that the major medical journals have a subtle bias against psychiatry in terms of what they publish, which is to say, you read New England Journal, Lancet, JAMA, a lot of the psychiatry articles traditionally are the meds don't work, the diagnostic system is broken, we're getting worse at treating these things. And I think that's somewhat different from other specialties. And I always suspected that, but could never really get data for that. And the traditional sentiment analysis tools in natural language processing have a big problem, which is when you start throwing psychiatric concepts at them, they immediately label them as negative because depression, anxiety, these are all things that reflect negative sentiment. So you need to be a little more sophisticated in how you do it. And it was always hard to get there. And it turns out this is an application of large language models where they're wonderfully good with very minimal training. So what we did in this project was simply pull in all the abstracts and titles in these major journals beginning in 2017 and present them to a large language model, again, a newer version of GPT-4, and say, after reading this article, would you feel more or less positive about a given specialty? So after reading this article about a new cardiovascular medication, do you feel more or less positive about cardiology? And the article is actually up online already, so I won't get into the weeds here, but the really consistent and striking finding is that articles about psychiatric topics tended to reflect more negative sentiment really across the board when compared to the 3 other groups that we looked at: cardiology, neurology, and oncology. Why didn't I do everything? Why didn't I go back further? Well, largely because it's more costly to do that at larger scale, but certainly we're in the midst of scaling up a little bit. But the point was, consistently these journals, when they talk about psychiatry, they frame it in a more negatively valenced way. And that's even with taking care to make sure that it's not just responding to terms in the title. And I'll tell you in a minute about how we did that. It also doesn't reflect differences in the year or the type of article or the journal. We were very careful to look for things that could confound this association. It's really quite consistent across the board. They're also less likely to publish articles that are positively valenced towards psychiatry, although the effects there are a little bit more modest. But as I said, most NLP tools will consider depression to be depressing, to be more negatively valent. So it'd be very careful and again, made use of GPT-4 in this case to permute the abstracts and the titles to change the specialty. So we take an abstract that's about psychiatry and we make it about something other than psychiatry, or we take an abstract about oncology and we make it about psychiatry. And what we observed was reassuringly little or no change and no meaningful change in the scores that we generated. We did some other control experiments to, for example, compare the scores to manual annotation. So food for thought, but more generally for our purposes, an interesting application of these models for different kinds of NLP than we could traditionally do. And of course, an obvious follow-on is to do this kind of thing with narrative notes and so forth, and we and many other people are in the midst of doing that. I want to switch gears and say a word or two about, as a journal editor, what I expect for generative AI, and this is maybe something that Martin and others will want to comment on. So we recently published an editorial in JAMA Open, basically because we're getting a flood of papers like this and wanted to lay out, here are the ground rules, here are some things to think about. So what we expect for articles that are submitted on generative AI, we want them to be clinically meaningful. Computer science is great. There are lots of journals for that. It needs to be meaningful to a clinical audience and understandable to a clinical audience. At the same time, we need to know the experimental conditions, even if a lot of it's buried in the supplement. Which model did you use? How did you set the parameters? Particularly important is sensitivity analysis. How much did you vary the prompt? What happens when you vary the prompt? What are the key elements of the prompt? We really are still in the early days of understanding how important that is, but pretty consistently it is the case that if you vary the prompt even a little, you can get very different results. Another really interesting area, and certainly something we want to see in articles about generative AI, are failure modes. When the model gets it wrong, how wrong is it? What are the ways in which it gets it wrong? And a particular case of this may be bias or fairness. Does the model perform differently in particular subpopulations? And I know we're going to address that in the discussion, so I won't say too much more about that, except we expect publications about generative AI to address this important topic. Are there human subjects protections? People seem to forget, at least in the papers, some of the papers I've seen so far, that raters can be human subjects, depending on how you're writing about them, that narrative notes often are going to violate HIPAA unless you have a secure way to process them. So again, just a reminder that human subjects protections absolutely still apply. And then two other key concepts: gold standards, what are you comparing it to? And then what's the context? What we really want to see is, for this model that you're playing with, what would it look like in the real world? What would it look like in clinical practice? Are you studying it in a real world setting, or a very unique subset or unrealistic subset? So those are the concepts we felt were important to highlight for submissions. And again, I'm sorry I can't be there in person. I hope we can have a interesting discussion. I'm certainly looking forward to it. Thank you very much.
All right, next we have Dr. Waqas Khan.
Hey, good morning, everyone. Thank you for coming. My name is Dr. Waqas Khan. I'm from the University of Toronto, and today I'll be sharing with you my presentation on the topic of how can we identify the aspects of AI-based large language models in psychiatry that pose the greatest risks and manage them. If any of you were in the previous talk just next door that might have just finished now, there's some overlap, but I'll go a little bit into more of the context and nuances. Just start off, there's no disclosures from my end in regards to this work that we've created at the University of Toronto. So just starting off the idea of risks of LLMs to psychiatry and beyond. So with the unprecedented rise of generative AI tools based on or trained on large language models such as OpenAI's ChatGPT, we've seen this reflected in it becoming the fastest growing consumer application, 100 million users in 2 months, from November 2022 to January 2023. And that's created a lot of importance because people have been excited on the opportunities and the prospects of these tools. But that also generates a lot of concern too in terms of the lack of safeguards or regulations to manage them. This has led to numerous major media outlets from the BBC, New York Times, publishing articles on the risks or the need for moratoriums to stopgap and just better understand the tool before we continue going forward. There's an open letter signed by over 30,000 tech leaders, regulatory bodies, heads, as well as academicians, healthcare professionals saying maybe we do need to slow it down just to get a better understanding of these tools before they're fully launched. Some prominent or common themes of biases or risks to LLMs include the hallucinations. These are when the outputs don't meet or match the inputs, so you produce false information in a way. We saw that with Meta's short-lived Galactica LLM, where they published an article on the health benefits of eating crushed glass, as well as another funny one was the speed of protons equating to the speed of light. Proteins equating to the speed of light. So it's very, very rapid as well. Another important risk would be the biases, that promulgation, that perpetuation of information that actually could be, damaging to healthcare in terms of patients, but also providers, that desire to maybe cause more damage or injury to those who use the tools, but also those who are affected by the tools. Some other risks that are becoming more prominent or more concerning or growing in media attention would be the patient data privacy, intellectual property, who does it belong to, medical malpractice liability, informed consent, fairness, data ownership, et cetera. So how do we understand, or how do we stop or understand or address these concerns? We look at guidelines, frameworks, regulatory policies. Currently in the United States, the FDA doesn't actually have a policy designed for AI or machine learning tools specifically, but rather it conceptualizes them under these medical devices. They are making policy. It's not yet there, but that's something that is to be aware of, or at least noted, that we're not fully there yet. The European Union has promoted this EU AI Act that was passed by the members of the European Parliament in June 2023, but now it's in the hands of each nation state to determine whether or not they should move forward with that and actually pass it or ratify it in their own parliaments. There are also other descriptive frameworks and reporting frameworks. These are made by institutions, organizations, companies, on how to better understand AI and systems or tools like LLMs in their own contexts. They can be quantitative or qualitative, and they all provide, including the regulatory policies, as well as these guidelines and frameworks, important matters to consider, or they all provide excellent criteria to consider when developing and also considering launching their tools. But unfortunately, they also lack something important: context. For example, safety. Whose safety? Is it the patient only? Is it the stakeholders such as the developers, such as the regulatory agencies, such as the healthcare providers or professionals? How do you assess safety? In what context? Is it only biological or medical, or is it only in terms of economic? There's not that the nuance isn't there yet. It's usually these generalized statements that we're seeing. And this led me and my colleague at the University of Toronto to develop this framework. We call it the biological, psychological, and economic social framework. As a psychiatrist, it plays off of that biopsychosocial model that we tend to use in clinical practice when we address a patient's needs or care. But it goes beyond that, because it also looks into this idea of AI, large language models, or any AI tools and systems, whether it be neural, whether it be machine learning. It can go with all other types of aspects of AI. It's novel because it allows developers as well as regulatory agencies to better understand how these technologies are safe to use or launch. So it's actually a stopgap before actually fully launching your tool. Maybe consider these concepts, these parameters. So more specifically, and we might have heard this earlier, it talks about the multiple stakeholders. We say patients, healthcare providers, regulatory agencies, and industry are important equally in terms of respecting their safety. And that's what we put at its core. Safety in terms of this biological, psychological, so health and well-being, medical implications, economic, economic burden or liability or litigation even. The social determinants of health, access, for example, would be one of them, equitable or quality access to services. To our knowledge, it's the first framework or guideline or policy to actually include the Hippocratic Oath of do no harm at its forefront for developers, implementers, regulators, and users' mindsets when determining whether or not it's safe to launch this AI tool, and if it's efficacious to some extent, as I'll speak on that later on. I say first, in terms of the do no harm, the Hippocratic Oath has been mentioned in several other AI guidelines and frameworks, but not in the sense of specific context, specific stakeholders. Who, again, are you doing no harm to? It's never really addressed. It's always these general statements, but we're saying these are people or these are stakeholders that we should start really considering when we say do no harm. This is just an example of how the tool looks. So we have the four stakeholders along the left, and then on the x-axis, you'll have the different criteria. What's unique about our framework, too, is that we're not saying it's exclusive only to itself. We're saying we actually want to work with all the other frameworks and different policies, that it actually complements them all, because they do provide an excellent criteria. But how that you get there, well, you can embed or, augment our BPS framework onto your current model. And it's not, and that's the unique novelty, again, of this tool, this framework. This is just an example of how it looks in terms of the figure aspects. Again, all stakeholders equally represented, because we need to understand that everyone has a vested interest in making sure these tools succeed. It's not only for one, it's for all. Within the middle, the core, we're going to include the different criteria. Again, those models of what we've modified from psychiatry, but a little bit more in depth and detail, the biological, the psychological, the economic, and the social. And so equally as important, what we found when we were creating this actual framework was that a lot of the research on AI tools tends to not be RCTs because of just the cost burden, but also just the difficulty of actually implementing an RCT. And that's important because then you're saying, how do we understand what's quality evidence-based? We're saying, well, why not look at why not create a translational scientific approach that uses what we already use in the pharmaceutical industry, or modifies that multi-stage trial approach, but make it a little bit more authentic, more less burdensome for developers, but also more time sensitive for regulators, for healthcare practitioners and patients. So we'd start off with a phase 1 quantitative study. That can be a prospective observational match cohort, just comparing or understanding the AI tool that you're developing compared to what's the standard intervention. Phase 2 would be more of that longitudinal. None of the tools, frameworks, or guidelines or policies have a longitudinal surveillance model in them yet. And that's what we saw with, again, I'm going to go back to Meta's Galactica. It lasted roughly 3 days once it was launched, because it was found to be so destructive, actually, or negative to multiple stakeholders, from the research community to the actual healthcare practitioners to the patient cohorts. Phase 3 would be a qualitative study designed because we often forget we need context to our findings. We don't know why we have these findings, because quantitatively we just see it there. It's statistically significant, great. But why? What makes it so important? What makes it so valuable? What makes it so authentic to those stakeholders that they value it, or they found these outcomes were something favorable or negative? And then phase 4 is what we'd say is you'd propose it to your regulatory agency, Health Canada in Canada, FDA, or the EU Commission in Europe, and say, these are our findings. What do you think we should do with it moving forward? And there's that discussion from there. So just to conclude, disruptive technologies have always inspired great hopes and fears, but many of these fears were ultimately unfounded. With the printing press, there was a fear of the erosion of moral values. With faster cars, there was the fear of internal organ damage. But predicting risks and development pathways of disruptive technology is difficult, and that's something we need to also step back on. We can't say it's so easy and we just need to just rush everything out into the market. But that doesn't mean we have to stop horizon scanning. We still have to keep exploring. We still have to keep bettering and improving. We just need to be slower or a little bit more cautious. We need to have periods where we can step back and say periodically and say, is this tool safe and efficacious, or are there risks to it? Just to get a better understanding of it. One of my favorite quotes is, the system is paralyzed by common assumptions. It wasn't the candlestick maker who invented the light bulb. And that's true. If we are always going to be candlestick makers, we're never going to go beyond and understand the beauty of light. But we still need to be respectful to the nuance and actually learn from it too as well. My colleagues and I at the University of Toronto believe our BPS framework does a lot of these. It's not perfect, we're not saying it is. There's always room for iteration and growth, but we think we address a lot of the concerns by including multiple stakeholders into our framework, by including that surveillance model into our framework, by including time-sensitive approaches, cost-beneficial and effective approaches, but also understanding that there is a need to continue growing forward, that AI and LLMs aren't an end-all, but they're something to help us as we grow in our practices, in our fields, respectively, engineering, science, what have you, social work, so forth. But we can still move forward with them, and thank you.
Thank you. So moving further into detail on the Perils side, or perhaps more some more practical guidance, we have our last speaker, Dr. Jina. We're doing great on time, so we have about 45 minutes left. Martin, you'll have ample time for discussion, and everybody who wants to ask questions will have plenty of time.
Thank you so much. Hi, everyone. My name is Jina. I work in the Human Understanding and Empathy group within Microsoft Research. I am a human-computer interaction researcher, and I have experience in building, designing and building technologies, AI intelligent technologies for mental health in both personal and clinical contexts. But I also have background in software development and testing. And today I want to bring that software development perspective into this discussion. And I want to discuss with you all how we might actually apply some of these responsible AI practices that we've been talking about to solve mental health challenges. And so AI has been touted as this magical tool. We've heard it from many speakers now. I probably don't have to repeat this. With the recent large language models like ChatGPT, it seems like the promise of solving mental health challenges is more plausible than before. We can have virtual companions, for example, we've already heard. We can imagine ways for having an always-on companion that can guide patients with personalized psychotherapy. We can digest countless documents to process real-time interactions to support clinical decision-making. But with the burgeoning of these technologies, unfortunately, we also know that AI systems have the potential to generate harmful content and to promote misuse in real-world scenarios. And so these risks include, leakage of sensitive information, or generating hate speech, harassment, or promoting discrimination, or even offensive content to specific communities, or dissemination of misleading content. And some of these harms actually go beyond individual health or even material harm. A negative representation of mental illness could further stigmatize mental health. And beyond specific AI harms, how we actually incorporate these technologies into the fabric of our everyday lives could also be harmful. So for example, the idea that AI can be your therapist on demand can bring short-term benefits, but imagine if all of the community decided one day to not have peer support anymore and decide to just use ChatGPT instead. What would happen to the society if that was the new form of norm? So what we can do about these potential harms in AI systems in the context of AI deployment, it's responsible AI, and it's simply this practice of ethical development of AI, although nothing in practice of responsible AI is simple. So for example, these are Microsoft's responsible AI principles that span across 6 different pillars, and this is one of many, many, many different ethical AI guidelines that are out there. And in practice, these principles aren't just followed by design or automatically. It requires significant amount of human oversight and work and investment to adhere to these principles. It involves impact assessments that we call, which is a deep analysis of how AI affects different stakeholders, where you consider different societal, cultural, and ethical implications, and implementing human checks and controls to guide the AI behavior, ensuring alignment with ethical standards and societal norms. Among many activities of RAI human oversight, one activity is called red teaming. Who here has heard about the term red teaming? Okay, a lot of people, a few people. The term red teaming is borrowed from military strategy, and it refers to the practice of adopting this adversarial approach to challenge strategies, plans, and systems to identify vulnerabilities that an opponent could potentially exploit. And since then, this term has been applied to technology. And in fact, red teaming has recently gained a lot of traction and attention as a method of ensuring AI safety. And with a lot of AI companies jumping to hire professional as well as volunteer red teamers, we also have hacker communities. Also, they've embraced that hacker mindset to break AI systems, but of course, these things are not fail-safe. And of course, this has become an important part of AI development as something even the White House is starting to mandate. And red teaming means many different things based on the target goal. So for example, in cybersecurity, red teaming involves simulating attacks on an organization's security infrastructure to test its defenses. In machine learning and AI, red teaming could be testing AI systems to uncover vulnerabilities, biases, or failure modes that could be exploited. This practice has recently been adopted to responsible AI, where RAI red teaming involves rigorously testing AI systems to identify and address ethical shortcomings on top of these other vulnerabilities. So think of cybersecurity and AI red teaming might be like jailbreaking your ChatGPT, but responsible AI red teaming would be having it spit out a racist comment or incorrect psychotherapy advice. So how would this apply to LLMs used in psychiatry? So one example, let's say we have a large language model powered psychotherapy chatbot designed to provide therapeutic support. A red teamer may trick this AI system to provide harmful advice or cause the chatbot to talk negatively about mental illnesses, or a red teamer may pretend to be from a certain demographic background and have the bot generate a biased response. In terms of the clinical decision support systems, a red teamer may test for complex or rare medical scenarios or force the system to inadvertently perpetuate medical biases with hypothetical socioeconomic background of patients. And of course, you probably shouldn't just brute force RAI red teaming with open-ended hacking because it can be inefficient and unorganized. So in practice, there are, I think, 3 key questions to consider when planning to do RAI red teaming. So they are who will be doing the testing, and then what will be tested, and how will the testing be conducted. So first, you need to have lots of people conducting red teaming activities. In general, we recommend having a diverse group of people and stakeholders, of course, that may have, they might have adversarial mindsets, they might have benign mindsets, they might have lived experiences, they might not, or they could vary across demographics or even disciplines as well, clinicians, non-clinicians, technologists, and non-technologists. The idea is that if testing is like finding a needle in a haystack, or in this case, a lot of different needles in a haystack, having multiple people with bringing in different lenses will help discover more of them. Applying this to large language models, in psychiatry, you may assemble a group of people like clinicians, community leaders, and maybe advocates, people with lived experience or no lived experience, a variety of demographics. But there are challenges, right? This red teaming now requires significant human resource. It's not just done on its own. But we already know that psych professionals and those with lived experience are really, really under-resourced. So also for those whose job is to think in this adversarial manner, and this is the one that I'm actually actively studying, red teaming activities can have a toll on their mental health. Being good at red teaming doesn't means that you can think like an adversary. So, being good at red teaming could be like you have to pretend to be a racist, right? But maybe that goes against your moral beliefs. So successfully getting an AI system to generate biased or triggering content can be fulfilling, but also engender guilt and negative self-perception. And what is being tested is another consideration, and there are two things to consider here. So obviously there's the system under test that is being tested, which presumably has a large language-based foundation model at the base layer. Perhaps this is the public open AI endpoint, or maybe your custom model. Then there are multiple layers built on top of that, including hopefully the safety layer that might flag harmful content or detect abuse, to the application UI layer that mitigates harmful use through maybe opinionated user experiences. At the end of the day now, the system is framed in a way to serve a purpose. So maybe you're saying that this is going to help with your cognitive behavioral therapy. So are you positioning it in an appropriate way with transparency and guidance? Then there are harms that you are testing for, right? You have the system, but what are you testing for? What are these harms? In absence of a harms framework or any kind of systematic way to categorize or conceptualize harms, you may need to discover potential harms through testing. And I'm hoping that, with more experience with these open models and available models, we discover potential harms. But maybe you take these discovered harms and turn them into more of a taxonomy like this. And in general, RAI red teaming relies on some characterization of harms to be effective, to be systematic. Otherwise, it's just open-ended hacking. And in fact, AI researchers and developers have been conceptualizing taxonomy of harms and risks that could arise from AI systems. But it's unclear if this taxonomy is actually comprehensive for psychiatry, and again, like for what application scenario and for whom, right? It's unclear where exactly mental health fits into this taxonomy, or if it's even possible to have a clear category of mental health harm. So in this taxonomy, the green box in the top left corner talks about mental health, like self-harm, over-reliance, treating chatbot like a human for virtual therapy cases. So applying this to large language models in psychiatry, I see two main challenges. One is that red teaming requires some technical understanding, enough to be able to imagine how the system may be broken or even fixed, and such technical understanding may need to be very application specific. Another is that most of the large language model harms are imagined and organized by non-clinicians, like me, or people without lived experiences. Much of the research work done in defining harms and mitigating harms remains in the computing field, unfortunately. This means that the harms or public data sets demonstrating these harms are rather generic and not specific to psychiatric or clinical settings. So, of course, it means that the mitigation may not be clinically sound. In terms of how red teaming is conducted, we don't really have answers yet, I don't think. The questions still remain on how we should be dividing the labor. Should it be open-ended, where everybody just jumps in? Or should one person be assigned to self-harm and another person be eating disorders? Should we have a dedicated team of red teamers, or should we just have volunteers that can be swapped in and out if they get tired? And then when is red teaming done? When are you done with testing? Is it when you no longer make changes to the harms categories or list of potential harms, or when you reach some sort of saturation? Is it just time-bound? You just do it for the amount of time that you have and then you're done? So the big challenges here is that we need to simultaneously optimize for the highest coverage of harms, which means potentially overexposing those that are actually testing, with the feasibility of mitigation, right? We can't spend all the resources accounting for all the edge cases, and the well-being of those that are conducting the work, and balance all of that with the limited financial and other resources that you may or may not have. And so how do we address the challenges of RAI red teaming? If you ask an AI or researcher or technologist, they will say to automate it, which they have tried to do. So many of these automated methods leverage, again, large language models for what they're doing is essentially expanding prompt sets expanding the prompt sets or conversations or scenarios to achieve higher diversity. and coverage using some sort of recipes or templates. So what they would do, for example, in this case, they would refer to harms categories to identify potential dimensions of adversarial evaluation, like maybe demographic variations or tasks. And then large language model would generate possible examples along those dimensions. Dimensions, and these examples are then fed into a template, which basically achieves combinatorial explosion of potential prompts that can be used to test the system, and then you would have to evaluate the output. And even if we have these automated methods, we can't get away with it because humans have to come up with the dimensions, they have to anticipate harms, make judgments on AI ethics, and review the generated harm. So basically, I scratched the tip of the iceberg today in terms of how, and I don't have an answer to this, how do we responsibly conduct RAI red teaming in psychiatry? I'm hoping that we can discuss that today. So 3 questions that I have is, who should be doing this testing? How do we get participation from everybody, but to do that responsibly? What are we testing? What are these clinical harms that we're testing? And let's get very specific, because we can't just have these generalized guidelines as we've just heard. And then how are we going to integrate this into our practice? Where are we going to get the money to hire the people to do the testing, right? So how are we actually going to do this, and hopefully upfront rather than this as a afterthought? So I went over time. Thank you so much.
Okay, so, oops, did we lose our slides? Let's see here. Okay. So we are doing good on time. We're entering into the discussant phase. So next we'll have Dr. Martin Paulus come up and deliver his comments, and then after that, we'll open it up to questions and interactive Q&A.
Well, I'm really excited to be here, actually, and I want to keep it very brief, because I want to actually engage everybody who's in the room and have a Q&A and a discussion. But I just want to, just by way of getting this started, want to just briefly review what we heard. Olu did a fantastic job in showing how he can transition from something that has taken him years to something that has taken him minutes, which tells you the enormous power that these systems have. Roy brought something up that is very important for us to think about, and it just came up on the very surface. He showed some very nice data, but he also emphasized what is the role of large language models in the editorial process in journals, because it is already happening on a very large scale, and we have to actually start thinking about what's truly the editorial process in large language models. And from Waqas, we heard the ethical and the framework that we have to generate to evaluate the harms of these systems. And then lastly, I thought that the red teaming approach is a very, very, it's something that I've only recently have identified, and it seems to me that this needs to be a practical approach that we need to bring into everything that we do moving forward. This and find ways of making this part of our development of the applications of large language models in mental health. So I think that all of the speakers brought on very, very important issues, and these are just one of the issues. I want to pick up a few points that in kind of going through that I thought is important that we need also maybe consider. I think we're very early in a revolutionary transition. And I think that this is also an interesting time point, because there's huge gaps between what we as mental health practitioners and mental health researchers do and what computer science and what AI researchers and what companies have created in a very and made public in a very short period of time, and these gaps need to be filled. And I think that was brought up in the last discussion, that we need to have the same people in the room. But it also means that there are resources that need to be made available to make this happen, and there need to be different organizations. They need to start thinking about how do we provide thoughtful resources to move this process forward. I think in terms of the second point, the enormous success of ChatGPT, I think, is in part due to its ease of the interface. It gives enormous power to an individual to query very complex knowledge structures. And I think we need to start thinking about what does that mean for an interface that we create in the mental health space, both in terms of the treatment and the clinical side, but also in terms of the research side. And as part of that, I think, and Olu really showed this very nicely, we need to put this all into a framework of randomized controlled trials. We need to create evidence base that is really at the highest level. And I think that there's a rush to use in many of these systems, but we really need to think about, and as part of if you put this into an RCT framework, then you can use the red teaming as sort of looking for adverse events. And identify adverse events that then need to be considered in the risk-benefit ratio of what you actually are doing. You know, we have chemotherapies that have enormous adverse events, and yet we're using them because they save lives, right? So we have to really think in terms of risk-benefit in this context. I do think that there is enormous value that can be created. Value both economic and value that is qualitative. And I think we need to communicate this. What is the value that we can create with these systems? But in terms of the economic value, we need to also think about what is it, what kind of organizations do we create to push forward this frontier that will provide value for those who seek value from an economic side and value from a more qualitative or from an academic side. This is a very difficult topic. And I think with these tools that make it so incredibly useful on many levels, whether it's writing notes, whether it is creating a treatment plan, whether it is doing a sentiment analysis of a complex medical record, with these enormously powerful tools, some want to rush and make money from them, quite frankly, very quickly, and others want to study them very deeply and want to understand how they work, how they go awry, and we need to find ways of bringing these groups together, because otherwise we can create harm unintentionally. So that's all I really wanted to say, but I wanted to really then bring it back to Nick and Sahib, and hopefully we can have a really strong discussion with lots of Q&A. So thank you all for coming, and thank you, Sahib and Nick, for organizing, and thank you for Olu and Waqas and Jina, and also Roy. I don't know whether Roy is still on the line. But everybody really was very enthusiastic about this, and I'm glad you all were here. Thank you.
Okay, so we've got a little more than 20 minutes to have some discussion. And true to form, I asked ChatGPT to come up with what it thought the discussion would look like. And there you have it. So you can compare what we're doing here with what's up there, and maybe somewhere in between. To kick us off, Nick is just going to give a few comments, and then we'll pass the microphone around to the speakers as we do Q&A.
Thanks, everybody, for coming, and to the speakers and Martin for their excellent comments. The title of this session was Opportunities and Perils, and I want to emphasize the perils a little bit. And for that, some backstory. So I've been working on the topic of AI impacts on society for probably close to a decade now, we started working with some of the social media companies back in the early days of social media and thinking about all the ways that social media could inform all types of things we can learn about humans and help people connect around the world and be this wonderful, optimistic force for good. And then I went to work at the MIT Media Lab where we continued that work, but we also started to think about how one can study machine behaviors and human-machine interactions and understand how those machines can influence and mediate human well-being. And in thinking about all of that, I got to know a lot of wonderful technologists and AI scientists and also a lot of good human behavioral scientists and medical scientists as well. And one of the things that struck me that we have persistently done so far is that people like myself, I would class myself as a tech optimist. I'm optimistic about the prospects of human ingenuity for helping humanity. We tend to overestimate the likelihood that the things we build will actually lead to the things that we want. And I think that we are at a point that Martin emphasized. We are on the precipice of a revolution. I'm one of the researcher access program researchers for OpenAI, and I was one of the first probably 1,000 people to see GPT-4 when it was released, and prior to that we were working with GPT 3.5, which was what most of you know as ChatGPT. And it was a stepwise function in terms of performance, in terms of quality, in terms of what it can do and how it can think. And I use the word think to mean in a sense like that. The models are extraordinarily powerful, and what they can do to our society is also extraordinarily powerful. And if we underestimate the downside risks, we may miss the ability to mitigate those in the way that we have previously. So what I would say is I think there are two perils that didn't really receive as much emphasis as I would put on them so far. And one is, I think that what we face with large language models is the potential to substitute what we think of as high levels of human cognitive and language performance with an algorithm. We face the ability to automate that. I put it to one of my colleagues as, the buggy replaced, the horse was replaced by the automobile. The horse and buggy was replaced. And we moved on. But the difference is that our thinking and cognitive processes in a lot of contexts are the horse in this case. and so we have to be careful with what that means for the disruption of how our economies function and how people who are our patients work, how they have jobs, what it means to be in society where what you thought was your skill, your natural language performance. I'm really pretty good at coding and actually pretty decent at writing, and GPT-4 is better than I am. And what does that mean for people's self-worth? What does that mean for people's ability to gain worth via their work? So that's one. I think the potential for economic disruption is there, and the thing that separates the economic disruption that is going to happen in the future from where we are today is a bunch of architectural and coding problems, that's system problems, but it's not technological problems. GPT-4 exists, and that risk is real. And then secondarily, I think we face a risk relative to the risk that we face with social media, which is that the hope is that these things can benefit knowledge and access to information and all of that. And I do seriously worry about the potential for the social isolation that has occurred as a function of social media to be augmented and amplified basically by having a really high fidelity friend that can remember everything about you, no friction, no conflict, and it can tell you all the things that it knows that you want to hear about yourself, and it can do it whenever you want. It's always there for you. It never forgets your birthday. These are real threats, and they're real threats for what it means to understand what the population threat to psychiatry actually is. So I just wanted to bring those two things up. I thank you all for being here today, and I'm really looking forward to the discussion.
Open for discussion.
Thank you for all the speakers. What an amazing panel. And I think for me, one of the things you did is you built a framework for having conversations, which is what we need. And I want to come back in particular to the framework that you discussed of the I'll call it the biopsychosocial and economic model, because the economic piece was, I think, one of the ones that we've left out of a lot of the other discussions. And I wanted to pose what I consider to be, from where I sit, one of the greatest dangers, and I think we haven't talked about it as much as maybe we could, and it's an economic risk. So when we talk about what's going wrong in our current mental health system, and we talk about, and a couple speakers have spoken about the rising rates of suicide and all sorts of other bad things in society, I think people often talk about, let's say, a shortage of treatment. But what drives the shortage, from my perspective clearly, is the lack of funding for mental health treatments. And if you look at the economics of the payers, mainly the commercial insurance companies and the federal government and state governments, they have systematically paid less for mental health treatments than they do for physical health treatments. And that's been established. The data is very, very clear, and there's some work on the federal level to address that. But my worry then becomes that the great technology that we're all here because we believe in and because we think it's going to help make things more efficient is used by those individuals who aim to save money to essentially say, oh, look at all these great things we have. This is going to be a way to improve things, but what they really mean is this is going to save us money. That is, we're going to decrease our reliance on the most expensive things, which are generally people, and we're not going to do what we're all saying, which is we're going to supplement clinical expertise, we're going to replace it. And not because it's good for everybody, but because it saves us money. So the question I wanted to pose to some of the panelists is, how do we think within the framework you've outlined? And I love the red team idea. So I'll tell you the red team I imagined, which is the red team for me is an unscrupulous for-profit insurance company, not such an unlikely thing, who says, let's take all the great work that's being done here and let's use that to make more profits, to save money, and to convince everybody that the future is less expensive. What do we do about that? How do we think about that within the framework you've outlined? Thank you.
Great question, challenging question. Anybody want to take it?
Thank you for the question. I guess within my topic or my discussion with the BPES framework, the biological, psychological, economic, and social framework, you look at those stakeholders and you see maybe for an economic benefit for industry, the stakeholders, it might be there. But from a biological, psychological aspect for the patient, the healthcare user, it's not there. From the social aspect, it's a matrix, right? So you can see that you might have one positive in a picture of many negatives. And that's when you can start addressing those kinds of questions or topics you'd have. You wouldn't have to then say that that one point is sufficient enough to move forward with that kind of approach, but we need to better understand it from these other stakeholders' perspectives. And that's why that BPS framework is there. Similar to the biopsychosocial model, it may work biologically, but psychologically and socially it may not be that therapeutic or valuable. So how do we get something that works with all categories or aspects? That's what I would envision for the BPS framework.
Yeah, I think you pose a really important question, and that's why I was bringing the economic aspect. I think what we have to prove as humans within that framework, that we add value, and that value has to be made explicit. And the only way we can make it explicit, we have to measure it. So I think, and that gets back to, we have to do the studies to show that actually humans matter. Because what you're saying is absolutely true. And in fact, we already had discussions with our health system. If we use AI, how can we save money? That's basically the bottom line question. And we have to then say, yes, you can save money, but you need humans to add value. And we can say that, but we have to measure it.
I have Roy reaching out from the ethers. The speaker's absolutely right. My health system turfs our own employees to one of these pretend mental telehealth companies. But really, if we measure outcomes systematically, we would know that these models either work or do not. Reality is we have an access problem, so these approaches are still likely better than nothing. Olu.
Yeah, I just want to add the point about the access problem, in that ultimately, even if it does save money for an insurance company, it still has to work for the patient. Otherwise, they're going to be paying later on, right? It's going to be penny wise and pound foolish if it doesn't actually work and it doesn't move the needle on clinical outcomes for patients.
So if I could just say something that I wish that were an effective argument against the insurers. So I speak as someone who runs a psychiatric hospital, and I always say this to the insurers, right? Like, why are you trying to save money by refusing to pay for this? And I'll tell you the answer that comes back to me, not directly, is that the commercial payers know that the average length that people spend on their insurance claim is 2 years. Meaning, all they got to do is turf the care and get them off their plan in 2 years, and mostly then they end up on Medicaid or Medicare where they're not paying. So I wish the financial incentives were aligned properly, but with our current system, their incentive is to wait it out, turf it to somebody else, and then not pay.
Yeah, that's a really good point. And I also wanted to highlight, I think the example that Jina showed where the National Eating Disorders Association, I'm sure people might have heard about this, they had they basically fired a bunch of their support staff, and they replaced it with an AI chatbot that was giving harmful advice, telling people how to have sustainable weight loss and with anorexia.
We need some collaboration with the laws.
Carrie.
All right, so wonderful session, and I don't know. I guess the question is, are we all going to leave more tech optimists or more tech pessimists? But trying to bring those two things together with the concept of if you can't beat them, join them. Right, the horse is clearly out of the barn. The thing for me that, and I think for most non-mental health people about red teaming was really the 2016 election and chatbots and social media potentially affecting the election, right? So that's real, and we know it's going to hit so much harder in 2020 in the next elections. Should we be actively creating positivistic chatbots in social media? Or at a minimum, at least, should Facebook and others be using AI to more properly police the systems against bad behavior? And then should we actually, as mental health professionals, be advocating for more socially positive messages through these things? Thank you. And the separate question is, can we just ask AI to tell us why humans still matter?
Yeah, you can do that right now. There's a series of pretty complicated questions embedded in that. I think red teaming, I'll answer in a general way. Red teaming works so long as the institutions that are underlying the actual implementation of the changes that the red teaming suggests actually implement those changes. I don't think that social media failed as an idea to bring people together because of something fundamental in the idea that you connect people across space and time. It failed because of the incentives of the companies that actually deployed the technology, and they needed to make money, and they figured out ways how to hack the dopaminergic system to do that. My advisor worked with Facebook in 2010, and it was basically a red team exercise. It was a large-scale experiment on Facebook to see whether or not you could change the nature of an electoral outcome by modulating some things on Facebook. They published it in Nature, and that was 5 years prior to the fact that that there were still those vulnerabilities that existed on the system because there wasn't really an economic incentive on the part of Facebook to try to fix some of those vulnerabilities. That's what it boils down to. And so all the red teaming in the world, is very useful, but the fundamental problem is the nature of the incentives that underlie the systems that we're putting these technologies into. And all the red teaming in the world isn't going to change those incentives, and if the insurers aren't properly incentivized to do the right thing, they can know the vulnerabilities and they're going to do the best they can to hide them. So, and I don't have an actual solution to how do you solve bots on social media.
Hi, fantastic talk. So like you said before, it's gotten a lot quicker. Most recently this year at an MIT reality hack that was at Red Bull headquarters, we built an AI chatbot for augmented reality for Apple Vision, and none of us had any training in that, a therapy bot from scratch. But one thing that comes to mind from these conversations is that most of the discussions about ChatGPT seem to focus primarily on the more consumer front-facing side, when if you go through the API and you utilize it in programming, there are actually a lot of options for safeguarding things. Even within in-worlds program, you can set parameters pretty easily to make it be that it doesn't give harmful advice. Essentially, things can still be generated, evaluated, and then it doesn't come out until you have some sort of like checking within that if it meets certain thresholds. And at least in the test that we did within a very brief 48-hour hackathon, we were able to make it so that it wouldn't give bad advice. Still, and then there's also more the added things of, in these conversations of redlining, I think that's one consideration as well, is because there are these abilities to make these more programmatic rules that can help with this, we still need to define what those rules should be, because then you can kind of address this preemptively so that you don't have, they put a Weight Watch app out on the market and it's giving these egregious advice, you already know that like you have to have some sort of entity or agent or evaluative way to be able to kind of make sure that it doesn't do this. Do you think there's a little bit of a black box problem that a lot of people don't know about these tools or these resources? They're not as well known?
I think one of the challenges that you don't know what you don't know, right? The problem with the large language models compared to traditional software or AI systems is that the possibility is endless, right? How it generates, how it hallucinates, you cannot really anticipate ahead of time what it would do. So even if you had all these meta prompts or layers, safety layers on top of it, even OpenAI had all those safeguards to say, I'm just an AI model, I'm not your therapist, right? I can give you medical advice type of safeguards. People have hacked around it. People can still get around it, and once that gets out of the bag, and people will reuse those hacking methods to get what they want and generate harmful content, misinformation, even sexualized images of children. So I don't know if I agree red teaming is not the only solution. What I want to promote is that I think we're going to get to a place where AI is going to be ubiquitous everywhere, and we just have to learn to live and manage the unanticipated errors during our development and deployment. How do we actually have processes and management in place so that when somebody discovers a jailbreaking method, that we immediately go and fix it? Because I don't know, the humans are really, really creative. They will find ways. They will find ways to break the system. There's this paradox also of automation's last mile. We think that we can always use automation to fix automation errors, biases and other things, but at the end of the day, humans, there will be always situations where that automation doesn't work and humans have to be involved to manually fix it, and then it's kind of this endless cycle, right? So how do we actually move past that and instead have a system or a process in place to quote unquote live with it? It doesn't sound great, but we gotta learn to live with it.
Okay.
Do we have time?
Yeah, we have time for one more question, I think. Two more. I didn't see the second person. We got you.
I have a red teaming anecdote, but I'll save that for later. My question is, there's a moniker that gets thrown around a lot now, which is that AI may not replace humans, but humans who use AI will quickly replace humans who don't use AI. And I think in the context of psychiatry, it sort of raises the question of training and education, that if we're going to create a workforce that knows how to use this, the AI stuff, which it's still actively being born, but how do we fix that gap between something being built, being in the market, there not being evidence for it, but still needing to introduce it into curricula? So, the world of psychiatry education, I don't know how well represented it is at this meeting, but it's not a world that moves fast. That may end up being one of the bigger questions out there, which is how do we quickly upskill to use these tools properly?
Olu?
This is something that we've thought about at UIC. I was part of a workshop on how to introduce AI into the medical school curriculum. And there was a lot of debate. There's some folks who feel like it should not be part of it, partly because the issue is that whatever you teach might be obsolete by the time people graduate or finish their program. So I think some of the things that were brought up in the other talks with regards to frameworks for how to approach and understand AI, I think should be incorporated into medical education as well as residency.
I would just add a note. I mean, everyone in this room who's gone through graduate medical education is a consumer of knowledge, and probably one of the most important things for us all is to constantly evaluate the quality of the knowledge that is coming at us. Increasingly, with the same human brain, we have more and more and more knowledge, right? That's one of the challenges with social media and feeds and streams. And generative AI or GPT, I mean, the amount of information that we have to process, it's only going up, which makes the decisions we make about how we use the information ever more critical. So if probably a good rule of thumb at a minimum is just to be generally skeptical of information that you're getting from these sources, unless you perceive value. And if you perceive value, maybe discuss it with somebody and see, well, am I the only one here? Because we know that there are early adopters of novel technologies, and those may be the people who replace the non-adopters or at least get a leg up. But at the end of the day, the technology will be around, and eventually everybody will have contact with it one way or the other. Last question.
Sure. So I'm a psychiatrist, and I've collaborated with physicists, engineers, et cetera, using large language models for a number of years. They're very powerful, and this was a good talk. I'm really struck by what Jina was saying about accuracy. We published a paper where we asked ChatGPT to find references. It gave us 35 who were accurate. It's kind of a little psychopathic in how assured it was. And so I have a philosophical question, and I'm thinking about the cost with Andrew, and Andrew's also a psychoanalyst. So what does it mean that we want our therapists to be machines and not people? And is there an ethical issue here where we're choosing machines as therapists, basically to save costs? You know, like years ago, I saw a talk by somebody, I'm sure they were very well intentioned, for a chatbot for schizophrenia patients who were lonely. And I thought there was something about that just struck me at some level as wrong. That really, if somebody is lonely, what they need is human contact. I just want to throw that out there.
Well,
Yeah, I think it's not just cost, though. I think about those early studies with, like, ELIZA, where people were much more forthcoming and honest with a machine, or knowing they were talking to a machine versus talking to a human being. So there is some benefit from having something that is completely objective, that's not biased, that's not prejudiced.
Oh, all
right?
of that. I mean, it's biased. It's
Well, the perception that there is.
Well, at least a perception.
And
like, for
is
example,
forthcoming necessarily a good thing? You know, we teach our patients, I think if we're good therapists, you don't want to tell everybody everything.
but you want to tell your therapist, right?
It's not in your interest. You have to protect yourself. I just...
Well, I just wanted to, in that vein, I just wanted to answer Carrie's questions. ChatGPT came up with 14 reasons why humans still add value, and I can send them to you.
Can I make?
Yeah, we're getting to the yeah. Go ahead, Bill.
This isn't even a.
Like, why are we asking...
I was wondering if next year we can get chatbot to give a talk about itself in one of these panels.
Yeah, well, that was going to be one of the
serious
comments
question.
You send your GPT and I'll send mine, and they can interact with each other and tell us what we learned.
No, I mean, to some of us, it's still, I don't use it, so it's still a pretty vague construct, but would it be possible to do something like that?
Like a workshop?
Yeah.
Have a talk.
Yeah.
An invited talk to ChatGPT.
I mean, I did earlier in the year, I did a grant writing workshop where I did some real-time demonstrations of how to actually use it as a co-pilot to develop and evaluate study hypotheses. We could do that. Waqas had a question, and then I'm going to end us with one final survey.
I just want to actually answer to that question that the lady's leaving right now, I think. No, she's not. Sorry. I'm from Canada too, so I'll say sorry a lot too. But no, I agree with what you were saying. And there's a very famous philosopher, semiotician named Roland Barthes, who said, in the future there'll be this desire for neomania, something new always. And that will cause a lot of devastation and destruction to human societies. And that's true. The idea I always think of is going back to foundational models, the biopsychosocial model, the not need for detachment of human interaction, but the need for maybe supporting or augmenting with some sort of tools that we can use as well. We augmented psychiatry with allied healthcare professionals, social workers, occupational therapists, so forth. there's always that need to augment with what we have to improve the system.
But a social worker is not a chatbot. I mean,
It's another opportunity to help, but that's how to respond, but there is value.
All right, I would like to jump in on this, just to say, I mean, I'm a pessimist about a lot of these things too, and I think that the potential for LLMs to supplant human-to-human interaction is very real risk. However, with some of the psychiatric treatment modalities, really you're trying to teach skills to people. And the ideal thing is actually that people have skills to interact with other people that they're friends with, that they don't need to go to psychiatrists in the first place to be able to deal with lots of their challenges. And so at a low level, if you increase access to some of the baseline basic skills in, say, CBT, without having to take, full use of the psychiatric system to be able to do that, I'm not necessarily opposed to that.
Tim Beck, who invented CBT, talked about the importance of the therapeutic alliance. And one of the ways that you teach skills about how to get along with other people is to model it.
Absolutely.
So,
and the more that you can get those skills out in the population, the more you can have peer-to-peer communication.
Yeah, and also, I mean, what about virtual therapy, right? I mean, is virtual therapy not human to human anymore? Like, should we be only encouraging in person, right? I think there's a slippery slope there, which is to say, like, no, well, but is it, right? You're interacting with it. You're interacting with their upper torso, right? Like, no, but I mean, the point is, like, the perfect is going to be the enemy of the good, given the access issue. So we need to really interrogate what we mean by human.
Okay, hang on.
Let me just say this. The large language models are not designed to be innovative in their interaction with you. Which humans are, and that's the difference between. I guess it can be. Not designed yet.
This is an exciting discussion. We'll need to continue it. I'm going to make one comment, and then I want to survey you again because I think it's really important before we go eat lunch. So one thing is when you think about psychotherapy, though, even for psychodynamic psychotherapy, it's done via language, right? You're listening to the therapist, even if they're the typical Freudian analysis, doesn't say anything. They're listening to the patient speak. So the communication and the relay of information is a vital ingredient, and large language models inherently utilize language that tricks the human brain in some very interesting, helpful, and potentially harmful ways. So with that in mind, I'd just like to survey everybody at the close of this very exciting discussion with respect to the field of psychiatry. How many of you think that the positive clinical applications of LLMs outweigh the negatives? A percentage in the room. More positive versus more negative. Just keep your hand up. About 50. And then more negative versus more positive. This is all informal. So we've got more than one, okay? Maybe 20% of the room. Thank you, everybody, for coming. This was wonderful.